Good afternoon. Our report will focus on the selection and streamlining formulas of oils and lubricants. And there will be two speakers. So my co-speaker today is Head of Product Management at Gazpromneft Lubricants, Nikolay Doroshenko. My name is N.Doroshenko. I'm Head of Business Development at Rubbles. Rubbles was set up in 2014. It's one of the key companies in data mining and using AI for business solutions. We work with a lot of industries. Since 2014, we've been working with the banking sector, with retail and FMCG since 2016, and since 2018 we work with industrial companies. We are based in Moscow, and we also have other locations where we have sales and marketing offices. So how do we work with AI? We have a set of technology which we call Rubbles AI Kit, which covers many solutions based on AI and ML, starting from data, processing data, then we build clouds, both on cloud storages and also at the service of the companies that we work with. There are some business-specific tools that we recycle from one project to another. Business-specific tools can be diverse. It could be a set of widgets for quick dashboards or pipelines for time series, detecting outliers. Business-specific tools are off-the-shelf solutions that can be used in many industries. So how do we identify projects where it makes sense to implement AI? There are three key criteria. First of all, the key one is savings. It needs to be cost-effective. And if you add AI, it could save even a couple percentage points for our company. And it has to be regular. The mid-level managers need to use it on a systematic level, follow a specific algorithm. So if you do it on a regular basis, then you will definitely get the economic effect that we're trying to achieve. And the second one is the presence of the data, sources of data. It would be impossible for us to build a model without data. We'd like to talk about one case study today that fits all the criteria. I'd like to give the floor to Nikolay right now. Good afternoon. Thank you so much, Jan. I will give you some background info on the lubricants. First of all, about Gazpromneft lubricants. We've been present in the market since 2007. We're a subsidiary of Gazpromneft. We do marketing, sales and production of lubricants. We have a broad portfolio, 700 SKUs, 700 products and more than 2,500 SKUs. We need to keep this portfolio up to date. We work with motor oils, industrial oils, specialized oils. But for this case study, we took motor oils to do the hypothesis and to prove it. It's the most representative case. As you can see, the number of R&D products is growing every year at our company. We have labs at our production facilities. We have 14 laboratory specialists. We have R&D engineers. And we have R&D managers. They have scope of activities or some technical requirements for a new product or a revised product. Requirements are evolving for lubricants, including for existing motor oils. And motor oil companies have to revise the existing portfolio, the existing production, in line with these new requirements to remain competitive and to continue working with the car manufacturers. So how do we come up with a new formula? It's a long process and time-intensive and cost-intensive too. First of all, we come up with some specifications, some kind of requirements. It also includes economic requirements. Then, based on our partners, we put together a prototype, and this prototype is then sent over to our lab, and that lab works at a particular production facility. So that lab really makes sure that the components that are there, the additives that are in this motor oil, are the right ones. And there are several iterations after a test of the blend. If it didn't fit certain initial requirements, then we revise the blend, we put together a new prototype, which is then sent for another round of tests. It is apparent that we lose time, resources, material, and chemical agents, whatever is used in putting together those blends. It could be up to, a lot of iterations. You could have products of different level complexities. It could be a general market product based on the existing prototype, and we just refine it and streamline at the production facility. Or we can come up with some original formula, a unique formula that has never been used before. So if it's really complicated, the number of iterations could be really high. In order to streamline the process, we need to use some automation. We need to cut the number of iterations, cut the number of time that is needed to put together those blends of motor oil. So we came up with a hypothesis that we have enough historical data, we understand what kind of physical chemical properties we need, we can use cutting-edge math algorithms to predict the properties of a finished product based on the initial physical chemical properties. We discussed this hypothesis with the Rubbles team. We elaborated this hypothesis. We had the KPIs in terms of the accuracy of the prediction. We received all the necessary recommendations on the dataset, on cleaning up the dataset, and after we did that preliminary work, we handed over the dataset to the specialist of Rubbles so that they could double-check on whether this hypothesis could be confirmed. Over to you, Jan. Thank you, Nikolay. So let's start with the data characteristics. Very often potential customers are really doubt whether they have sufficient data in working with formulas and predicting the chemical and physical properties of the finished product. So we got the data set, which had only 900 blends, but as we realized later, these data were sufficient to build a model. Formulas could consist of a different number of components, and you can see the normal distribution. Most often, we have 6 components. To the right, you can see that there could be different types of the blends. What do we mean by the type? These could be the number of components and the number of properties. About 45 types of the blends were encountered just 1 or 2 times in the dataset. In terms of the completeness of the dataset, we were aware of some of the physical chemical properties. They were auto-filled for almost 100% of the blends. So we can see the data on the kinematic viscosity. And these are the first and the second diagram. But the third diagram says that we didn't have data for CCS at minus 35 degrees centigrade. This is why it's all red. It means that the data are missing. So as I said, we do have almost 100% for most of the blends, and for some of the blends we didn't have any data at all. So what was our approach? We believe it's a relevant approach for a vast number of tasks in AI application in the industry. The first one is you need to dig deep into the subject matter. And definitely third-party experts helped us, including the team led by one of the professors on the chemistry of the surface. So we looked at methodologies that are used in that area. Here's one of the formulas. Here's one of the equations that allows you to calculate the binary viscosity. So you can see the kinematic viscosity and then the rate of the incoming component, and the third one is the adjustment parameter. And in order to use the classic approach, we also use machine learning. In particular, we use the gradient boosting under decision trees and various libraries of optimization. Assembling was key. We put together both approaches, both methodologies, and we also added on top of it ML approach. So what was the outcome? Well, let's look at the target. What was our KPI for us? As Nikolay said, usually engineers need between 7 to 10 iterations to get to the target and to predict the physical-chemical properties with the necessary accuracy. We had a target, as you can see it. Kinematic viscosity is the top line, so it has to be plus minus 0.5. And in 80% of the cases, the model does hit that target at first attempt. So if you compare what was before and what we have today, you can see that we can hit the target at first attempt with a probability between 65 to 88%, while humans can get to their same target after 7 to 10 iterations. So we also looked at kinematic viscosity. We decided to look at a specific property. So we have the residual at 100%, at 100 degrees. So you can see the target interval and the accuracy. In more than 79% of the cases, so we hit the target at first attempt. And the lower diagram shows you the absolute error of prediction. We use cross-validation. We split the entire sample into several parts. So we do the training for 4 parts and then do prediction for the 5th one. Then we do the training for the first 3, and then we do the prediction for the 4th one. So as you can see, the model is pretty stable.
Что опять же внутри нашего целевого интервала и говорит об устойчивости модели.
Over to you, Nikolay. Thank you so much. We were positively surprised by the outcome. and our hypothesis was reaffirmed. It was a joint effort with Rubbles. We initiated an internal project, and it's still being developed by our in-house team. We see that we get added functionality, and we understand that we can have even better prediction going forward. So there is a lot of room for potential. So what we've done is just stage one. It's been successful. So we predict viscosity of the base blend. So we work with the basic components of the polymers. We can predict the physical properties of the end product, but we also need to model and imitate specific properties, individual properties that will depend on additives. You need more competence, more skills and knowledge, and we'll definitely need to gather the data, some experiments, and then we will add this to our model. Going further, we need to predict and model lubricants in the engine tests. So for our industry, including in Russia, this sequence, increasing the complexity of R&D tasks, is quite the classic approach. All the Western and European trends will definitely have an impact on our blends and on our methodology. We understand that today the speed of change is increasing, the life cycle of a product is shrinking. We are forced to use this new technology to be looking at ways to streamline these processes, to improve efficiency in our R&D. And this particular case reaffirmed that we are experts in lubricants, and we understand how we can design a particular product, what are the principles and properties of the legal requirements in particular industry. But even as you begin a project, you need to have a third partner who has this cross-cutting experience, who knows how to gather the data and train the data, because a lot depends, your success depends to a great extent on the quality of the data. This is why we want to continue working with this company. We hope to find even more exciting solutions, maybe from some adjacent industries. So we believe that this technology could be introduced not only at our company. We believe that oil refinery companies will only benefit from the introduction of AI. Thank you. And as a wrap-up, this case study has confirmed that AI could be applicable in updating existent and designing new formulas, in predicting physical and chemical properties of finished products. And again, it is relevant not only for oil refinery, but also for other industries. It could be petrochemicals, it could be metal alloys. ML coupled with deep knowledge in the subject matter apparently ensure that you can reach the necessary economic effect in updating the existing portfolio and designing new products. Thank you. Yes, and on my part I would like to thank all the participants of this conference, the organizers. It's a great pleasure for me to be part of the forum, which is whose topic is far away from what we usually deal with. But again, AI has really helped these main industries that we represent. You could really boost your efficiency, and it's really great to communicate with specialists in AI. We are learning. We're always learning something new, and thank you.